Okay, good evening, geometry peeps. We are going to look at rationalizing the denominator, which is, of course, making sure that we don't have a radical in the denominator. Whenever you have a fraction, the proper way to present that fraction is to not have a radical, square root, cube root, etc. in the denominator of the fraction. So we want to rationalize that denominator. What we're going to end up doing is getting rid of that square root. Okay? So the first thing we're going to do is to get rid of the square root that's in the denominator is we're going to multiply the fraction by the actual radical that's in the denominator. So here I've got square root of 3, so I'm going to multiply that square root of 3 times square root of 3. Now, remember, if I want to keep the fraction the same value and have it maintain its value, I have to multiply by something that will keep the fraction the same value. And if I multiply the bottom of the fraction by square root of 3 in order to maintain the fraction's value, I have to do the same thing to the top, the numerator of the fraction. So whatever I do to the bottom of the fraction, I must do to the top of the fraction, okay? I know I put that dot there, it might be a little confusing. So I'm going to come across here, and then I can't multiply what's outside the radical times what's inside. So I've got 9 square roots of 3 on top. And then square root of 3 times square root of 3 is square root of 9. And what's square root of 9? 3. Okay? So now I've gotten the radical out of the denominator. So my next step is going to be, can I reduce this fraction? And the answer is yes. This is all multiplication. This is 9 times the square root of 3. Everything on the numerator is multiplied, so I can reduce. So 9 and 3 have a common factor, which is 3. So I'm going to reduce here. This becomes 3, this becomes 1. So my completely simplified answer is 3 square roots of 3. And that's how I solve 9 divided by square root of 3. Now, let's look at the next example. You're not always going to be able to reduce. So let's look at this example. Okay. First of all, I have 7 divided by square root of 5. I don't want that radical in the denominator, so I'm going to multiply by square root of 5 in the denominator, which means I also have to multiply by square root of 5 in the numerator. The reason this works is because technically, what is square root of 5 divided by square root of 5? 1. So you're multiplying by 1. That doesn't change the value of the fraction. Same thing here. Square root of 3 divided by square root of 3. That's the same thing as multiplying by 1. It's not going to change the value of the fraction. So this is in turn going to give me 7 times the square root of 5 on top. And square root of 5 times square root of 5 is the square root of 25. And the square root of 25 is 5. Now, if I look at where I am now, do I have anything that can reduce? And the answer is no. There are no common factors between 7 and 5. So I'm going to box in my answer. I'm done. Now, one thing I want to point out, let's look at the previous example. When I reduced the 9 and the 3, I didn't bother the 3 under the radical, did I? You cannot divide this by 3, this by 3, and this by 3. That radical means that that's a completely different value. You can't reduce using the same factor outside the radical and under the radical, because that means something different. So that's why I only reduced the 9 and the 3 and did not reduce the 3 underneath. So you've got to understand that, because a lot of times you'll come up with some similar numbers or factorable numbers. They appear to be, but you're not going to be able to reduce them because under the radical gives it a whole different value. It's like apples and oranges. So just like here, I can't reduce the 5 that's under the radical and the 5 that's not under the radical, because that square root sign gives us a completely different value. Those are not reducible. Okay? So that's how we can look at those. Now let's look at a couple of other examples here. So let's come down here and create something that might be just a little bit different. Let's say I've got 2 square root of 3 divided by square root of 5. Okay? I'm going to look at this and approach this in the same way, because I do not want the denominator to have a radical in it. So I look at the denominator, and what do I have? Square root of 5. So to get rid of that, I'm going to multiply by square root of 5. What I do to the bottom, the denominator, I must do to the numerator. So I'm going to multiply across, and here's where it gets a little tricky. Remember, apples and oranges, just like variables. 2 is going to stay here, and then I can multiply under times under. I can't multiply outside times under, but I can multiply under times under. So 3 times 5 is the square root of 15. I can multiply those two together. They're both under the radical. Square root of 5 times square root of 5 is square root of 25, which of course is 5. So when I look at this answer again, can I reduce this? And the answer is no. This is as simplified as it's going to get. I can't reduce the 15 and the 5. The 15's under the radical, the 5 is not. Okay? So let's look at one more example for rationalizing the denominator. And so we'll create something like this. I'll do 4 times the square root of 2 over 5 times the square root of 3. So this is as complex as you're going to see it. Again, use the same rules. I don't want a radical or a square root in the denominator. So what radical am I trying to get rid of here? Well, square root of 3. I can multiply the entire bottom of the fraction by square root of 3 if I wish, or I can multiply it by the whole thing, 5 square roots of 3. It does not matter. I will do it both ways, but multiplying by the entire denominator will just create an extra step where you have to reduce at the end. I'm going to concentrate on the radical piece. So I'm going to multiply by the radical, which is square root of 3. And remember, I have to do this on the top as well. Again, this is just like multiplying by 1. It's changing the format of the fraction, but not the value. It's the same thing as changing 1/2 to 2/4. Same fraction. It's the same thing as multiplying by 1. You haven't done anything special. So here I'm going to multiply across. Now, I can't multiply the 4 times these two, but I can leave the 4 here. And then square root of 2 times square root of 3 gives me square root of 6. And then on the bottom, I've got 5 times square root of 3 times square root of 3. Square root of 3 times square root of 3 is square root of 9, which is what? 3. What's 5 times 3? 15. Okay. So now I'm going to look at it and ask that same question. Can I do any reducing here? Well, I can't reduce the 6 and the 15. The 6 under the 15 is not. And the 4 and the 15 don't have any common factors. So that's my answer. Now the question is, when are we going to use this as a, what we're doing in class right now? And the answer to that is going to be when we are doing our special right triangles, when we do our 30, 60, 90, and 45, 45, 90. So, for example, if I gave you a 45, 45, 90 triangle, and I gave you the hypotenuse, say it's 11, and I wanted you to find the legs. Remember, the pattern in a 45, 45, 90 is the hypotenuse is leg times square root of 2. But when you go from hypotenuse backwards, when you go from hypotenuse back to leg, you're going to be dividing by the square root of 2. So to find these two guys, which I know are the same, it's going to be 11 divided by the square root of 2. So you see how that creates a situation where I have to rationalize the denominator. So I have square root of 2 on the bottom, so I'm going to multiply by square root of 2, and I'm going to multiply by square root of 2 on the top. So I will get 11 square roots of 2 on the top. Square root of 2 times square root of 2 is 4. Square root of 4, which is 2. Cannot simplify, and you're done. So that's how we would apply it in a 45, 45, 90. Now, if I had a 30, 60, 90, which is the one we've just started learning about, remember, in a 30, 60, 90, the little side is doubled to get the hypotenuse, and you multiply the little side by square root of 3 to get the medium side. However, what if I presented you with a situation like this where, okay, I'm going to cross these out. Let's say I gave you the middle side instead, and I made that 8. Instead of going from little to middle and multiplying by square root of 3, how would I do it? I would go backwards and divide by square root of 3. So I have 8 divided by square root of 3 to find this side. And again, I need to rationalize the denominator. So I'm going to multiply by square root of 3 over the square root of 3. So 8 square roots of 3 over, and you're getting the hang of this. Square root of 3 times square root of 3 is square root of 9, which is just 3. Cannot reduce that anymore. So this side is indeed 8 square root of 3 divided by 3. Now that I know the small side, how would I find the hypotenuse? Well, the hypotenuse is twice as big, right? The hypotenuse is going to be twice as big as this one. Well, all you do is double this number, because what you're going to have is 8 square root of 3 divided by 3 times 2, right? Which is the same as 2 over 1 because you're doubling it. What can I multiply together? I can multiply what's outside. 8 times 2 is 16. What's left on the inside? 3. And then 3 on the bottom. And I can't simplify that. That's as simple as it's going to get. So this would be 16 square roots of 3 over 3. And that's how you would apply it to a 30, 60, 90 triangle. Peace.